This video is for exponential functions from finite differences. Again, we're going to look at a growth function and a decay function. All right, so we've got a table of values. We know this one is a growth. So the first thing we're going to do is identify the change in x. So here, the x are increasing by 1 every time. Then we're going to find the common ratio. So we work backwards. 6 divided by 3, 12 divided by 6, and keep going. So every time we do that here, the ratio is a ratio of 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So the value of a represents 0, a, the initial value or the y-intercept. So my y-intercept here is 0, 3. So a is going to equal 3. The value of b represents the base of the exponential functions or the common ratio. So here the b value is 2. So exponentials are a lot easier to write than some of our other ones. And so we're going to graph the function, and we can graph it from this. So we've got 0, 3, which is going to be way down here. 1 and 6, which is still pretty far down there. 2 and 12. Let's see, 4 and 48 starts getting up a little bit better where we can kind of see the growth. 5 and 96. So somewhere in there. 6 and 192. So exponentials, you do have to estimate quite a bit. So that is the information from the graph. What we know is that this graph is going to go on and on forever in both directions. So the restricted domain is from here to here, is from 0 is less than or equal to x is less than or equal to 6. And the restricted range, so from 3 to 192. All right, so from now for a decay one. So we're going to identify the change in x. So the change in x is 1, and then the common ratio. So again, we're going to divide. And you always want to check to make sure that it's constant. So 3,200 divided by 12,800, we get a fourth. 800 divided by 3,200, we get a fourth. 200 divided by 800, we get a fourth. And so, again, always check all of your values, but the common ratio here is 1/4. It's going to stay 1/4 the entire time. So the y-intercept, 0, 12,800, that's our a value, 12,800. Our b value is the common ratio. And so another little thing, if you want to work backwards, say you want to know what the growth rate or the decay rate is. So up here, my common ratio is 2. So remember that 1 plus the rate gives you your common ratio. So R here is going to equal a 1, which is the same as 100%. So this one we have a fourth, so I'm going to go ahead and make that a decimal. So 1 minus the rate gives us our common ratio. And so here, R would equal 0.75 or 75%. So for this table, it's decaying at a rate of 75%. So again, just kind of a refresher from Algebra 1, what all these numbers actually mean. So our function here is going to be f of x equals, I put a 3. It should be 12,800 times a fourth to the x. All right, so graphing this one. So we're starting at 0, and then 12,800, 1 and 3,200, 2 and 800, and 3 is when we really start getting close to that asymptote. We're going to go all the way to 6. So remember, we're never going to cross that x-axis. And then again, this graph is going to go on and on in both directions. These points are just for our restricted domain and range. So our restricted domain is from 0 is less than or equal to x is less than or equal to 6. And then our restricted range is going to be, remember we start at the small, so 3.125 is less than or equal to y is less than or equal to 12,800.